Hello my dear student. In standard 11th we reached to the lecture number 11. Okay, it is lecture number 11. And we were studying the vector analysis. Okay my dear student. In a vector analysis we have reached to certain points. We have discussed the resultant if this is the triangle and the two vectors are inclined at an angle theta, if the vector A and this is the vector B, alright, and this is the angle theta. Okay, then the resultant we obtain here are A square B square plus twice AB cos theta. Alright my dear student, yes, using parallelogram law, if you will draw this one, you will see this two vector like this way. This one you can add this vector from here, the result is not going to be changed. This will be the resultant. Here also this will be the resultant. You can see both the resultant same. Whether you are using parallelogram law or the triangle law, the resultant not going to be changed, it remains same. Okay, so this R vector which is A plus B, so its magnitude, that is the magnitude of R, that is the magnitude of A plus B is A square plus B square plus 2AB cos theta, that we have studied. Okay my dear student, yes, if any vector is in form A plus B, then we got this one. We have also studied the angle between this resultant, that is the alpha, that is the resultant makes the angle alpha, and it was tan alpha, it is B sin theta over A plus B cos theta. This was the direction. Alright, direction of resultant we have discussed till here. Remember student, if any vector is added like R is A plus B, alright, A plus B, then you are having the resultant, this one, A square plus B square plus 2AB. Let me write again, A square plus B square plus twice AB cos theta, where theta is the angle between these two vector. Alright, but if you are having any resultant, it is A minus B, then what will happen? The resultant will be A square plus B square minus 2AB. Remember, cosine angle. Again, theta is the angle between vector A and vector B. Remember, don't confuse. We have studied till here. I am repeating, okay, again and again. All the things might be the similar thing, because this is very important my dear students. Remember, you are studying the vector, and this is very important for your standard 11th and 12th. This is not a topic, a chapter actually. This is the helping element. This will be used as an instrument, like the mathematics you use as instrument for physics. The same way this vector you will use as an instrument. Okay, this will simplify your physics. This is the language of physics actually. All right my dear student, one more thing. Suppose if we are having a vector R as xi plus yj, we have discussed already, again I'm recalling, and if you represent over this axis y and x, alright, so the magnitude, actually try to see this vector over this axis. This is xi and this is yj. and the resultant looks like this one. Alright, my dear student, and this is the angle. Suppose no, it is alpha. This alpha is the angle between resultant and vector x, and here the angle between vector x and y, it is how much? 90 degree. All right, so you write the magnitude of this vector r as mod of r as root under x square plus y square, and tan alpha you write y by x, that is the angle of resultant with the x-axis, and you use tan beta as x by y, that is the angle beta is the angle of resultant or the direction of resultant with which axis? With y axis. In very detail we have discussed. Okay, my dear student. Now here, if the resultant is in this way, xi minus yj, so the magnitude will be root under x square plus minus y whole square. It remains same, magnitude remains same, x square plus y square. Now again try to look over the axis y and x. Let me draw x and y. This is the x and this is the y. This is the x-axis. Alright, now the resultant looks like this one. Whether the angle will be positive? No, this is negative. Now you can find here directly the tan alpha. What I told you, you have to find the direction with the x-axis, so you will write x below as denominator. Now y by x, but you can see the coefficient of j, it is minus y. Here minus y, you have to write the coefficient of j divided by the coefficient of I. Remember, to find the angle with x-axis, if you want to find the angle with y-axis, then you have to write the coefficient of I divided by coefficient of j. Here the coefficient of j is minus y, that's why. Okay, and this alpha is negative. Why? We are going here the clockwise. The clockwise angle you have studied in standard 10. The clockwise angle always measure as negative. All right, so this is negative and this is positive. There will be a number of questions, my dear student. That's why I'm just enabling you to understand all the things. One more thing, my dear students, I forgot to teach you in unit vector. Try to remember the magnitude of, in note point in your notebook you will write the magnitude of any unit vector. Okay, this must be 1. All right, what does it mean? If you will put this I cap inside the modulus, you will find 1. The magnitude of any unit vector, actually any unit vector, whatever may be the unit vector, a cap, I cap, j cap, whatever, so the magnitude is 1. Why? Because we know that the one vector will have only one magnitude and only one direction. One magnitude, but the value of magnitude can be anything, but the direction is only 1. Okay, that's why here the magnitude is 1. So okay, now let me wrap this. We'll discuss few more things. Okay, now the next. Suppose, my dear student, you are having a vector. All right. One more thing, my dear students, I would like to request you all, if you find any mistakes, okay, in my lecture, kindly notify in comment section. You can use that comment section so that I can rectify, okay, further. Otherwise, the rest student will study that wrong thing. Okay, but I'll rectify in the comment section only. Now we are going to do some practice what we have studied till now. Okay, suppose the two forces are acting. Okay, the two forces are acting at a particular mass at a particular point, and we have to find the magnitude of resultant as well the direction also. All right, so here I'm going to give you some forces. We have to find out the magnitude and direction of the resultant. Okay, so here we go for the first example. On the x and y axis, this is very important. Here the one force, it is acting parallel to the x-axis, Suppose this is the force F, all right, and another, it is also the force identical, all right, yes, interesting, and both are acting at 60 degree, all right, it is acting at 60 degree, and it is asked to find the magnitude and direction of the resultant. Of course, if two forces are acting at this point, if this mass is free, this mass will not move along this force or this force. It will move towards along the resultant of these two forces. All right. So we have to find the resultant magnitude, how much force is acting, resultant force is acting. You cannot say the 2F is acting over here. So we have to find the resultant magnitude and also what will be the direction of that resultant force. Okay, my dear student. So here I am going to let me set the board a little bit. You might feel problem due to this focus. All right. Here, the resultant, my dear student, we know using you can solve this question by the two method. Okay, one, it is the component method, and the second that you can use that formula. First, that formula resultant, we know that resultant force, this is the force, and which force? It is the resultant force. This resultant force can be written as A square plus B square. Okay, at the place of A we are having one force, and at the place of B we are having another force, and both are same in magnitude. So it is the F square plus F square plus twice F square cos 60. Am I right? Yes, cos 60, it is 1 by 2. Remember, it is 1 by 2. So we can put here F square, and it will be the 2F square, or F square, 2F square plus this is 2F square times 1 by 2. It will be the cancel out. So we'll have the resultant force, it is root 3 F. F square will be out of the root with the F. All right, and this is the answer. But how you will find the direction? You cannot find the direction using this one. All right, so we are going to solve this by the second method. Remember, wherever you are asked to find magnitude only, directly you will use this formula. Remember. All right. Now the second one, the second method. My dear students, can we write? Actually, both are the vectors. So we are going to write here the two vector, the sum of the two vector. All right. This vector already we are having on over the x-axis, so we can write Fi cap, but this vector is not over the x-axis, either on x-axis or y-axis. So let me break the component of this force. Okay, the component of this force can be written as, this force will have the component here, it is F cos 60. Am I right? Yes, F cos 60, one component, and another component will be on this axis, it is F sin 60. F sin 60. Now we are having the total forces. You can see it is F sin 60, F sin 60, and the two forces here. Okay, one it is F and second it is F cos 60. Now this is the x-axis and this is the y-axis. Now we can write the resultant force here, the F resultant, as in vector form, my dear student. It is F plus F cos 60, that is the F by 2 I cap, plus F sin 60, it is F root 3 by 2, along the y-axis it is j cap. Now simplify, this is 3 by 2 F I cap plus F root 3 by 2 j cap, and this is the resultant force. Now you can see we have just formulated, we have just converted this force over the x and y axis. Here the coefficient of I is 3 by 2f, coefficient of j is f root 3 by 2, and we know that these two are perpendicular to each other. You can see this force and this force are perpendicular to each other. It's very clear. And if two forces are perpendicular to each other, then we know the formula of magnitude. What we know actually, mod of Fr, my dear student, it can be written as root under, okay, suppose this is the overall Fx, So we can write fx square plus, if it is fy, then fy square. Now it is very simple. Root under, it is 9 by 4 f square plus this is 3 f square by 4. Now you will find the same answer. What we have? Root 3f from here also. This 2, okay, this 4 actually, LCM. So the 9 3 is 12 by 4 f square root under, and this is the f resultant. So the f resultant, it is root 3 f. So we got the same answer, but this was very easy, sir. What is the benefit of this one actually? What we have done actually here? My dear student, the benefit of this one, you can find the direction of force easily using this one. And sometime you need to know this one also, how to find the direction. Okay, otherwise you will be confused. I will teach you the number of ways to find the direction, but this one is also one of the important method. Now, how will find the direction, sir? Remember, the resultant of these two forces will be somewhere here. All right, Fr. But with respect to the x-axis, we have to find the direction. Suppose it is the angle theta. All right, we have to find the tan theta. So tan theta, we know that we have studied that to find the direction of one vector with respect to the x-axis, we will keep, if tan theta we are going to find with the x-axis, we'll keep the coefficient of I, that is the coefficient of x, as denominator. Now, where is our vector? Our vector is over here. You can see this is our vector. The coefficient which is over the x-axis is 3 by 2f. 3 by 2f. And the coefficient with j, it is f by 2 root 3. Root 3 by 2f. Alright. F will be cancelled out. 2 will be cancelled out. So, finally we have the root 3 by 3 and it is 1 by root 3. So the tan theta, here, tan theta, it is 1 by root 3, it means theta is how much? It is 30 degree answer. So this is nothing but the 30 degree. So resultant is inclined at 30 degree. In this way, you study how to find the resultant. Okay, my dear student? Yes, be careful while you have to find the direction of magnitude also. Okay, so I'm rubbing this one and I'm giving you a homework. Remember, my dear students, you will ask for this assignment. I'll give you assignment. I'm not giving the homework over here. I'll give you the assignment. There will be a number of questions. 80 to 90 questions will be there for your practice. Okay. So you'll ask for the assignment, my dear student. Here. Okay. Let me give one question. Here the one force, it is F, and the another force, it is suppose this one. Okay, this is the F and this angle is 30 degree. You have to find the resultant magnitude of resultant force Fr and theta, the direction of resultant force. Okay, this is x-axis and this is y-axis. If the question will be in statement, the question will be written, the two forces are acting at an angle, so that one force makes 30 degree with the y-axis and another it is along the negative of x-axis. Find the resultant force and also find the direction of resultant force with x-axis. Okay, my dear student. So this is your homework. Now the next example. This is also very important. Kindly write down the question, my dear student. I'm dictating the question. Two forces, 8 Newton and 5 Newton. Okay, two forces, 8 Newton and 5 Newton are acting. Okay, two forces, 8 Newton and 5 Newton acting. What will be minimum and maximum resultant? This is a question. What will be the minimum and maximum resultant? Okay, if you can solve, try to solve. Now let me give the answer. if one force is 8 Newton and another force is 5 Newton, okay, so the maximum force will be when we will add in same direction that we have studied. So the F max, it will be 13 Newton, not more than that. Very clear. And minimum force will get at which angle? We have studied the different cases. If the two vectors will be inclined at theta equals to 0 degree, 90 degree, 180 degree, we got the maximum resultant when theta is 0, and we got the maximum minimum resultant when theta is 180 degree. Alright, so 180 degree, it means this vector will flipped like this way. Okay, it means the minimum will be 8 minus 5, it is 3 Newton. This is the answer. Okay, now the next example, my dear student. At what angle, kindly note down the question, at what angle two forces, again 8 Newton and 5 Newton, okay, at what angle the two forces 8 Newton and 5 Newton are inclined to have the angle, sorry, at what angle to have resultant as 10 Newton. You need to find the resultant as 10 Newton. What should be the angle? Could you solve, my dear student? Yes, if you can solve, this is your homework. Try to solve. The very simple, my dear student, the very simple question. Now another example. Okay, at what angle two vectors incline to have resultant magnitude of same as either vector? This is the very important. Let me solve this question. You are having two vectors. Suppose one vector A and another vector is also A. The two identical. At what angle two identical vector incline? These two identical vector are inclined. Okay. At what angle? You have to find the theta. This is the example. You have to find theta. At what angle these two vector are identical vector are inclined so that the resultant of these two will be same as the, okay, resultant will be same as the magnitude of either one. You have to find the angle. Okay, how you will solve? Try to solve. Pause the video, my dear student, and try to solve this question. Okay, let me solve this question. Here the resultant can be written at the a square plus b square plus twice ab cosine of angle. Alright, but if the resultant is a square plus twice a square cosine angle, a square both side, you will find a square as 2a square plus 2a square cos theta. Here the a square minus a square will be 2a square cosine of angle. Alright, so the cos theta, it will be minus 1 by 2. It will be cancelled out. Minus 1 by 2, and theta is 120 degree, because cos 120 is minus 1 by 2. So the angle is 120 degree. This is the answer, my dear student. Okay, now the next question I'm giving you. Class 4. At what angle, this is also your homework. Okay, this is the homework. At what angle the two forces 8 Newton, okay, F1 8 Newton and F2 5 Newton are inclined? At what angle these two forces are inclined to get the resultant force of 1 Newton, okay, 2 Newton. At which angle you will incline these two forces if the resultant force is 2 Newton? Okay, my dear students, this is your homework. You must solve this question and you will send in group. Now, next question. Today we are doing practice over the theory that we have studied till now. Find angle between vector A and B. We have to find the angle between A and B. You have to find the angle if magnitude of vector A plus B is equals to the magnitude of vector A minus B. Okay, this is a question. How you will solve this one? Very simple, I think. You will find the magnitude of this two. So the root under A square plus B square plus twice AB cos theta is equals to root under A square plus B square minus 2AB cos theta. Am I right? Yes. Here minus we are using because it is minus. Alright. We have studied right now. For the A plus B it is plus theta. A minus B it is minus theta. Squaring both sides, you will find this A square B square cancel out. Alright. And then it is 4AB cos theta, it is 0. Then cos theta is 0. It means theta is how much? 90 degree. It means the angle between A and B is 90 degree. How? Let me. Here the angle between this vector A and B, it is how much? It is 90 degree. You can see this particular thing by making, okay my dear student, by making the diagram. Suppose this is the x and y axis. Okay. For the first one, A plus B. Okay. For first one, A plus B. Suppose the two vectors A plus B are inclined in such a way. I think I have not taught you the position vector. It would be a little bit difficult to understand you. Okay. I'll teach you after the position vector. Okay. Now, another example. Try to solve. Write down the question, my dear student. If resultant of two identical forces, suppose F1 is F and the F2 is also F, the two identical forces, all right, like this one. If resultant of two identical forces is root 3 times the resultant of the root 3 times the magnitude of either force, root 3f. Okay, then find angle between two forces. You have to find the angle between F1 and F2. You have to find the theta. Could you solve? If you can solve, pause the video and try to solve. Here. Now, look at here. We are having the formula FR. It is F1 square plus F2 square plus 2 F1 F2 cosine angle. Since the resultant is root 3f and the forces are identical, so the f square plus it will be the here the 2f square plus f square, and it is the 2f square cosine angle. Squaring both sides, you will find the 3f square minus f minus 2f square. Alright, this will be toward this side. 2f square, it is 2f square cos theta. Here the f square, it is 2f square cos theta. Cancel out. That is 1 by 2. 1 by 2. It is cos theta. So theta will be 60 degree. That's very simple. If the two identical forces are inclined at 60 degree, the resultant will be root 3 times f. Okay, my dear student, we have studied here few question how to solve, but the number of question you will find in my assignment. I hope that you will ask for the assignment, and in next class we will study how to find the unit vector. Okay, how to find the unit vector. I'll give you some questions to find the unit vector. Okay, so this is all about today's lecture, my dear students. Thank you very much.